Okay, great. So we can continue. And fortunately or unfortunately, we're gonna continue with probability distributions firstly. So we're gonna just use the same formulas that we used in the first few slides about orderings. So with an example, it would be easier to imagine the situation. So let's have one team that should be formed of two, but we have to choose from a group of 4 men and 4 women. But we have to choose only 2 people for the team. And X would be the event having a certain number of women in the team. So we have a few cases. So the first one, if calculating the total number of outcomes, it doesn't matter how many men or women would have. That means having 4 men and 4 women, 8 people in total, and we have to choose from 8 people only for 2 positions. So that's 8 factorial divided by 2 factorial times 8 minus 2 factorial, which in the end would be 28. Nextly, if there are no women at all, only men, that would mean that we have to choose from 4 men, we have to choose 2 positions. And from 4 women, we have to choose 0 because we don't have women, we don't have 0x. In the end, the first part would be equal to 1, and the second part would be equal to 6, which in the end would be 6. After that, if we have just 1 woman, that's the same as before. But now we have to choose from 4 women, just 1 person. I'm sorry. And then if you have 1 man, if you have 1 woman, it means we have 1 man. So we have, again, choosing from 4, just 1. 4 times 4. And if we remember those numbers, we can conclude that if we have 2 women, I'm sorry, if we have 2 women, we can choose from 4 women just 2, the same as here. It will become just 6 cases. And if you remember all those numbers, now I'm going to show you in the next slide. The same team, the same women and men. And we have 0 women. The probability is 6 over 28. Why? Because the total number of outcomes is 28. But we are interested in having 1 woman, or 2 women, or 0 women. And in case we have 0 women, it will become 6 over 28. If we have 1, 16 over 28, and so on. So we just plug in those numbers in the table in order to get them for easier. And we are now going to the probability functions. We just have to not calculate, but draw the graph of that table. What do we see here? We have x-axis, which shows A, and y-axis, which shows F. Why we use the probability functions? We use them because it's easier to imagine the distribution of outcomes. For example, are the probability of having more women more than just having 0 women? For example, that's the easiest way. And here, if we have, imagine here it should be X, not A, but now I'm gonna, if we have 0 women, it means that we have 6 over 28. That means from 0 to 1, we have the probability of 6 over 28, which is here. If we jump with 1 woman more, it would become the probability of having 1 woman is 16 over 28. But if we jump to having 1 more, the cumulative distribution function, we have to sum up those 2 numbers. It means that the probability of having at most 1 woman, which means having a 0 or 1, which would be 22, which is right here. And if we go for 2 women, it means having those 3 together with plus. And as we remember, in the end, we should always equal to 1. If it's not 1, we messed up something. The numbers are not correct. The end probability of having at most 2 women should be in the end always the end of 1. So now we can go on and see what it looks like if you have to calculate those. For example, f. Maybe, for example, let's start from f from 1.2. What would be the answer? If I say that, for example, 8 f from 1 would be equal to 16 over 28, which is right here. I'm sorry, it's plus, so it should be 22. I'm really sorry, it should be 22. Over 28. What would be your suggestion? Having 1.2. Can we have a woman and not 1.2 women? Can we have that?
No.
So it means that
Only 1?
That's right. So we just have f from 1. It doesn't matter if we're counting women, people, oranges, chocolates, whatever. It's always, we have to think that way. F from 1, we already know that it's 22 over 28. So let's now see what would be if we know, what would be if we have to determine f from minus 10. So it means that minus 10 is somewhere here. And this is our function.
Zero then. No?
That's right. Because minus 10 is here, and it means that it's 0. And if you want to have a look for 1, we have 1.2. If you want to see, here, for example, is 1.2. If we just see where the function goes here, it should be equal to 22 over 28. What would be the answer for 7.8? For example, somewhere here is 7.8.
Yeah, just 1 then.
Yeah, that's right. Something to remember is that you cannot have, again, something different, more than 1 or less than 0. When you have f, it's always between 0 and 1. Like here in the table. So let's continue and see if we can. Okay. So now we're going to see, for now, we were having a look at the discrete probability distributions. Now we're going to the continuous one. So let's imagine the example, but now we are traveling from Eindhoven to Tilburg by train. And we know that the train departs each full hour. So it's either 1, 2, 3, 4, etc. But you don't know the schedule beforehand. So firstly, we have to see if x is discrete or continuous.
Continuous?
Continuous, that's right, because it says departs each full hour. It doesn't say minutes, hours, measured by days or whatever. So it's continuous. I'm not sure if it's necessary to, but I would say just C. What are the outcomes of X?
Ooh, 0 to 60?
That's right, okay. Because it says explicitly that it departs each full hour. So it's already given. It can't be more than an hour. And of course, we measure in minutes. Nextly, we have to determine the corresponding CDF and PDF. So now we're going to explain what is the difference between PDF and CDF. I'm not sure if you remember those from the lecture, but that's an example exactly from the slides. Maybe you can remember, I don't know. Firstly, I would say to have the distribution function, it would be easier. What the distribution function means? It means just to write with letters and numbers our cases. Firstly, if we have x 0 than less than 0, what would be our function? It would be just 0, because if we just sketch it up, we have less than 0, which means on the left side here, somewhere here, which is basically 0. If we have x between 60 and 0, for example, here is x. Here we would have x over 60. And that's our point. If we have more than 60, we just have a look at the function and we have just 1. And what's the main purpose of the distribution function? We just have to explain for all values of x, it doesn't matter, less than 0, whatever, what our function will look like. And our graph would be equal to just that way. Because why? Because we have depart each full hour. So it means that our x changes accordingly to how it changes, basically. It's really stupid, but it is true. Because from 0 to 6, it changes. After 60, it's always 1 hour. You cannot, it's just 1 hour. And before x, having x less than 0, it's always 0, because you cannot wait minus 5 minutes. You cannot wait minus an hour. So now this would be the CDF, and CDF comes from the cumulative distribution function. It's cumulative because it shows us we sum up all the numbers, and in the end should equal to 1. When it equals to 1, it's cumulative because we sum up all probabilities, and in the end they should be equal to 1. The PDF, it's something different. The PDF, it shows for each separate value, each own number of the function. What it means is basically that if we have 60 minutes, we are waiting for 1 hour, we are just waiting that number x. If we are waiting less than 0 minutes, we just have 0. And if we wait more than 60 minutes and more, including 60, we would wait for 1 hour. If we wait for something about, for example, 5 minutes or 30, for example, 9 minutes, we would always wait 6 minutes. I'm not sure if these examples shows you clearly. The most important thing to remember that CDFs shows all probabilities sum up together. If I can go back to the previous slide here. This here should be the PDF because it shows separate probabilities. If we have the CDF, we have the cumulative. So for example, here we have the cumulative because in the end it's just one. And if we have to draw the PDF for that example, for the teams, if we have 0 women, if we have 1, if we have 2. For 0 and 1, we would have 6/28, which is here. If we have 1 woman, it will be 16/28, which is here. If we have 2, we will have again 6/28. That's the cumulative distribution function. So now I want to go back. Oops. Okay. So let me clear all of those because we need space. And now we have to determine the probability of X being more than 45. What would be your suggestion? Maybe a few seconds to think about it. The probability of X being less than 45 is just F of 45. And we know that the maximum time we can wait is 60, so it is basically 45 divided by 60. If we have to calculate the probability of X being between 10 and 30, that's a bit more complicated. What would you say? And if we imagine that is the timeline, we have 0 here, and the maximum here is 60. And we are interested between those two numbers.
We should just divide the 30 divided by 60 minus the 10 divided by 60.
Yes, that's right. We just minus the whole part, that whole part minus this one, which in the end should equal to 20/60, which is just 1/3. And the probability having exactly to wait 59 minutes. Not more, not less, just 59, sorry. but the answer should be the same. So
I thought that wasn't possible because it is continuous.
it is continuous, but we still can wait 59 minutes. We
Okay.
cannot count how many cases we can wait. We cannot count, we can wait for 1 minute, for 1 minute and 10 seconds, and so on.
Okay.
But we need to calculate.
Okay.
It's really simple because we have at maximum 60 minutes. That means exactly having to wait 59 minutes. It means that's just 1/60. Because we have 60 minutes, like the time interval between we arrive and the train comes. 60 is the maximum. That's the same if it was like the probability of having to wait just 5 minutes. Or just 20, whatever you like, 41, for example. If we have equals, it means that is just one case of the whole interval, time interval. If you have to arrive at the station now and see that another person is already waiting. So we have already two events. Maybe you can remember about conditional event. So express the conditional probability if you're given that another person already waits for 15 minutes. How would you express this one?
Can you just replace the 60 with 45?
Where to replace 60? Where are you looking at? At which equation?
Oh, I don't know, the x has to be between 0 and 45 now.
Yes, exactly. Because we already know that for the past 15 minutes there was no train if that person is still waiting. So the moment you arrive and see that someone is waiting for 15 minutes, we have to think, okay, so the train comes at maximum 45 minutes. He cannot come in 1 hour anymore. So we have the probability of x being more than 30, given that the probability of Higgs is more than 45. And now I will explain. We have to wait for at most 45 minutes. And we already know that because we already know that for the past 15 minutes there was no train because of the other person. And we can just express the conditional probability. For example, if you have to wait more than 30 minutes, if it was saying, what is the probability of having to wait more than 30 minutes? Based on that, another person is waiting for another 15. So it would be expressed in that way. If it asks, what is the probability of having to wait more than 5 minutes, knowing that another person was waiting for 15 minutes, it would be just, instead of 30, it would be 5. This is just a way to remember that we have conditional probabilities and how we can express each other based on each other. So I hope that was not confusing. That's the answer. And we can just go through, that's the calculation, but that's not important right now. It's important to understand that we have another event that we are somehow connected to. So now we're going to expectations and variation and standard deviation. The first thing that I would say is that those formulas looks awful, but it's easier to use them. So yes. First one, what's expectation? The expectation is basically the average value, the mean that we expect to have in the end of the experiment, of the random experiment. The variance is, for example, we already have the mean. For example, the mean is 5, the easiest example. And the variance shows us how much we can expect to vary between the mean and our value, the sequence. For example, let me have the pen. We have the mean of 5. That's the mean. And the variance, how much varies between those numbers. The standard deviation, it's it's basically the root of the variance. That's easy to calculate, but it's also how many standard deviations we can deviate from one of the numbers we can have in the sequence. For example, is 1, but that's really far from the mean. So how many deviations we deviate from the mean, that outcome. So one example, if we have two variables, x and y, and we're given the expectation, the variance of x, and the expectation of y. We have to calculate those. And here it's about linear transformations and how can we use the information of x to calculate the expectation of y. I would say just use this formula. I'll give you 2 minutes to write it down and see if you can get a number. Did you get a number or do you want me to start solving the exercise together?
Yeah, can you explain it?
Yeah, sure. So we are given the expectation of x and the expectation of y. And we have to calculate the expectation of that equation, basically, consisting of x and y. And it's basically the expectation of x, but 2 times, because here we have 2 times x, minus the expectation of y, but 7 times, because here we have 7, plus the expectation of only 8. That's just dividing and making separate parts of that equation. It's 2 times x minus 7 times y plus 8. But we already have the expectation of x, which is just 4. So it becomes 2 times 4. It should be 8. Then we have the expectation of y, which is 8.5. 7 times 8.5 equals to 59.5. In the end, we have the expectation of 8. And that's my question. How much is the expectation of weight if we know that the expectation is just the mean, the average? We just have one number. It's just 8 because we don't have an equation or we don't have a sequence of numbers. The expectation of 8, it means that it's just one number and we have to see what's the average of that number. And the average of that number is 8. If we have, for example, the average of 1 and 3, that would be 2 because 1 plus 3 divided by 2, it would be 2. The average of that sequence is 2. But when we have a sequence of one number only, that's just the mean. And now we just have to calculate 8 minus 59.5 plus 8 should be equal to 59.5 minus in front. We just divide the equation and calculate according to the numbers in the exercise that were given. So now, what would be the variance? The variance of the same equation. I would say here it's not, I thought it's 8 minus 8, but it's not, it's 16 plus this number. So it should be
Why? Can you explain what you just did then again?
yes. For the mistake I did, right?
For why we changed the minus 59.5 to a positive number?
Because I thought that here I thought it's minus 8 plus 8, and I just thought that they kill each other and it becomes minus 59.5, but it's 8 plus 8. Here we have 2 times x, which is 2 times 4, which is 8, and then plus the expectation of 8, which is 8. So that's a stupid mistake of mine. I'm sorry. The variance, yes, sorry.
No, I was just thinking about the question before, because wouldn't it be plus 16 minus 59.5?
Yeah, that's right. Yeah.
Oh, yeah, okay. Then I
Thank
get
you. Yeah. I'm sorry. And now the number should be in the end
minus 43.5.
0.5. Yes. That's
Okay.
yes, that's correct. Okay. Thank you for for mentioning that. We have the variance, and how do we calculate the variance? We just have our number x minus the mean that we already have. On the second square, on the square, which is here. And here we can find it, just write b. We can just find it as it follows. We have the expectation of x is 4. And we have 4 to the power of 2 is 16, which is that's the mean, because we have the mean and we have the x, and x, how much is x? Is 17. And we have 17 minus 16, where 16 is 4 to the power of 2. And that is easier to calculate already, it becomes 1. I would say it's easier to remember the shortcut formula that is just x to the power of 2 minus the expectation of x, the whole brackets to the power of 2. That is the shortcut that gives the same result as this one, but it's easier, and we use this one here. I will delete this one, not to confuse you.
Can you explain b again?
Yes. The variance, if you have to remember one formula for the variance, it has to be this one. This is kind of, it's just unnecessarily complicated the things if you have just x. We just find that the expectation, we are given in the x test, we didn't find it. The expectation of x is just 4. And the expectation of the square of x is 17. And we just plug in those numbers here. We know this is 17. And we know that part. So we can easily put it on the power of 2 and have 4 squared, which is 16. And we have 17 minus 4 squared. That's basically the product of the square of the expectation minus the expectation of the square. But I think it's, yeah, just easier to remember this one. I'm not
Yeah.
sure. I would just write it that way. That's the one to remember. And we have to, if we have to calculate the variance of u, and u is given by minus 4 times x minus 3. Here we can have a look at this formula. And I'll explain it in a second. The variance of U here we have B, and we know that B is in front of X. So B is here, -4. -4, the formula says we have to make it to the power of 2. We put 2 times the variance of X and in the end we have just -3. We just write it there. And looking back in the exercise, we already have the variance. We don't have, but we can calculate it. Here, this number is 16. The variance of X, we can calculate by the variance of here. We already calculate the variance of X, which is 1 here. And just 16 times 1 minus 3. We use just what we just calculated. I see. Do I have a question? I think you might have a question. We just have to extract those numbers that are in the brackets here. And just to make them in front of the equation and calculate the according numbers. Just remember that part here, that rectangle.
Yes, so what's the answer of that formula?
The answer of U should be 13.
Oh, yeah.
Do you need a minute to take it as a note? Yeah, sure. Yeah, sure. And the last question asks us for the standard deviation of -4 times x plus 3. The formula here says we just have to take the absolute value of b, which in our case is just 4, which would equal 4 times the standard deviation of x. We know that the variance of x is 1. We already calculated that. So the standard deviation would be just the square root of 1. And this is just 1, which makes it 4 times 1, which is 4. Do you want to explain something again or?
How do you get the 1 in the
In
left?
B, we get the variance as 1, right? Here.
Yeah. So you just take the variance. Yeah, okay, I get it.
We calculated the variance, and the formula here says it's just the square root. The variance is mu to the power of 2, and the standard deviation is just mu. I would suggest to clear everything of that slide and continue to an easier one. And at the end of the crash course, I have, I think, 1 or 2 more exercises about linear transformations as we did right now. And I think, yeah, just to take a breath from those hard formulas. Whoops. Here, we have again an exam exercise, and I'm going to leave you maybe 3 to 5 minutes, let's say, just read it and try to think about it. Did you do the graph and do you have an idea how to just sketch the exercise?
I did a constant line between 0 and 10.
Why? Between 0 and 10?
1 and 10.
1 and 10. Okay, 1 and 10 is okay. So we just have a constant here. In 0, maybe with another color. And we have 0, everything that is beyond 1 and beyond 10. And we have just one rectangle. It says determine this PDF. What we should do? We have the whole rectangle, and here we know that is 9, that interval here. But we don't know here what the number here. But something that we can do in order to understand, if we remember everything below the probabilities, in the end sum up to 1. So it means the whole area below that chart, that bar, should be 1. So that's a rectangle, so that's good. So we have that side multiplied by this one should be equal to 1. So let's say this is A. And we would have A times 9 equals to 1. So then A becomes 1 over 9. If you have a graph, it's easier to imagine what's the area below and to calculate it then. If we have to continue to point B, we need to determine the distribution function of x. What was the function, the distribution function? It just shows for all values of x what would be f from x. So it is just, let's see, imagine x is less than 0. What would be f of x if we have a look at the graph? If x is, for example, minus 5.
Then it is 0.
0, yes. And if x is between 1 and 10, what would be the number here? Let's imagine here we want to calculate for 6. If we have to calculate for 6, we have to calculate the area of that rectangle here. So it would be, the first side should be 6 minus 1 times 1 over 9. Why? Because we already know A. And 1 over 9 is a constant. It's always 1 over 9. It doesn't matter the number here, what we choose, what we go for. It's always 1 over 9. It will become in the end 5 over 9. But that's just for 6. If we have to take a random number, let's go for x. That would be x minus 1, because that side here should be x minus 1 times 1 over 9. And for x bigger than 10, should be just 1 over 9. And 1 over 9 is an A here. So if you have something above 10, for example, 15, here should be just 1. Sorry. But that's because we already know the end, and the end should be always equal to 1. That's the sum of the probabilities in the end. That's called the distribution function, just showing for different values of x what will be their function. So now for C, if we need to determine x being between 2 and 5. You already had a similar exercise. Do you have a suggestion? if I just make a hint that way.
Yeah, between the first brackets, the 5, and then
Okay, and then the 2.
Yeah.
And do you know the numbers? Can you find those numbers from the distribution function? We can just easily plug in the number here. So if you plug in 5 here, it would become 4.4 over 9 minus 1 over 9, which is 3 over 9, the end, 1 over 3. The answer is 3 over 9. And the next question is the expectation of x. What was the expectation? Was the mean the average of all values? So it means if we have all values between 1 and 10, the expectation would be the mean, the average. What would be the average of that period? Do you have an idea?
What was your question?
What would be the average of that period, the mean between
5?
1? Sorry?
5 maybe, or
But we start from 1, not from 0.
yeah.
0 is somewhere here. So
So 4.5 then.
4.5, okay, that's the start. 4.5, and we have to add 1 because we are already one step further from the 0. And if we have to look at the 0 infinity line, this thing here should be equal to 5.5, which will be the mean of the sequence between 1 and 10. And that should be equal to 5.5. I'm not sure if you're familiar with integrals that should be done with them. I'm not sure if you solved exercise with integrals. You did?
Yeah, we did.
Okay, so I can show you just to have some space below. Okay. That's the integral, and above we're gonna put the maximum, which is 10, and then the minimum, which is 1. And then in the brackets, we would have our function that we already did in question B, I think, yeah, in question B. We just take our variable is x, but then we have the formula is x times f of x, and we have to make the derivative of this one. But we already know that our function is this one here. So we already know that it's x times 1 over 9. Why? Because here it's 1 over 9. And that is the end result of the function. What would be our equation if that's the derivative of it? We just have to make it, if we have here to the power of 1, here we will have to the power of 2, because the derivative of x to the power of 2 would be 2 times the 2 times x. But here we have x times 1 over 9. So here it should be 18, 1 over 18. If you take the derivative of this one, it should be equal to this here. Should be 2 times x times 1 over 18. Which is x times 1 over 9. And in here, we have to substitute with 10 and 1. Firstly, we have a look at 10. We just substitute here. It becomes 100 divided by 18 minus, now with the minimum value, which is 1, it becomes 1 over 18. And again, that is 99 over 18. And now I'm going to calculate it. It is exactly 5.5, which we did just with the time value, with the timeline. Do you have a question?
No, it's clear for me.
Okay. And I hope for the rest, just get the chat. It's not clear. Okay. Which part was not clear? I guess that part is way too much for now, but I would say just imagine the timeline and imagine putting your numbers from the exercise there. I will take the eraser and do it again. That is the timeline. We have 0 here. And that's the infinity. In our exercise, we are interested in the interval between 1 and 10. And that interval is long 9. So if we take the average, the mean of that period should be 4.5, because 9 over 2 is 4.8. But we know that we don't start from 0 here, we start from 1. So we just have to make one step further, 1 point on the right in order to get it right here. Because we calculate 4.5, based on that we start from 0, but we start from 1. If here was from 0 to 10, it should be just 5. But we start from 0, so it should be here 5.5. We have to take into consideration that the 0 is before the 1, one step back. Just one quick question. If you are asked to find the expectation, for example, 9 in the period 2 to 9, what would be? Just type in the chat if you have an answer. $4.5? Is that your suggestion? Unfortunately, not. But I would say, first step, just see the interval. It's long. How much is long? It's long 7, right? And the average of that period only, it's 3.5, which is just 7 divided by 2. But we have to take into consideration that we are on the line, and we have to know where the 0 comes. It's on the left hand side, and it's 2 periods on the left of 2. So we just have to add up to 3.5 plus 2. So that would be our medium. The medium, the average, the mean, what do you call it? It's 5.5. Did you get it, Pratik? Yes, okay, great. I see we are just 3 minutes before 5, and today's session is until 5. Do you have any questions from today's material? Was it hard? Am I talking too slow, too fast? Maybe not too slow, or not explaining enough, or just too much drawing, which tomorrow I won't be doing because it's not so clear when I draw so much.
Oh, it was fine for me.
Okay. It was okay. Do you need more exercise to include or more theory?
I would say this is a good balance.
Sorry?
I would say this is a good balance between exercise and theory.
Okay, good. Okay. And maybe tomorrow in the end, we're gonna have a few more exercises. A lot more if we have the spare time to solve them. Otherwise, I can just show you the exercise and show you the answers, and you can calculate them home and ask me if you need to compare or just to find a solution. In the meantime, if you need anything help for something, yeah, you can text me or just send me an email. I'm not sure. The first slide was. Let me go back to it. It's here. So that's my number and my email. If that's all for today, we're until 5 today, right? I'm not wrong. Okay, great. So tomorrow morning we are again at the same time with the same stupid statistics, and hope it's gonna get better. And yep. Thanks for the feedback, and I hope I'm gonna get better. And now I'm gonna answer Evelina's questions, and yeah, that's all for now.
Okay.
I hope, yeah. Sorry?
Thank you.
Yeah, thank you, Sue. And see you soon. See you tomorrow.